Yeah.
Yeah.
So please, people can sit on top of each one. So.
Okay, guys. So at last we're starting. Sorry for the delay. As I said before, a part of our video gear has broken this morning, alas. But now everything seems to work fine. So, on behalf of the whole organization board, I would like to welcome you to EuroPython 2012, and I'm going to leave the stage for the introduction of the conference to Valentino Bolonghi, who is the president of the Python Italia Association, and Fabio Pliger, who is a member of the PSF. So, give them a warm welcome.
Thank you, and welcome everybody. Welcome to the hottest week of the year, literally. So I'm very happy to see all you guys here and many friend faces and many new friends. And this year is the hottest and the biggest EuroPython ever. We had around 770 attendees. Yeah. And we worked very hard to bring you the best EuroPython ever. We did a lot of work on many sides of the conference, many parts of the conference. And last year we had good feedback, and we had like this 10% of increase over the last year. So we we are glad to bring you the conference. So if you want to talk about EuroPython, want to tweet and tell people what's happening, please use the hashtags EP2012 and EuroPython and talk. Hopefully good things, but if you have something to complain, do it. And this year, you have the QR codes on your badge. The badge is somehow the same as the last year, but we inserted the QR code. It's only on one side. This is a bug, and we'll fix for the next year. It points to your profile, and whenever you find a new Pythonista, you can scan your QR code, and our application, the website, will link your profiles. And it's only on the EuroPython web application, but you'll have the chance to just, when you go back home and want to see everybody that you met here and recontact them, you can do it. So this should improve your chance to make friends, to talk, and have a better experience.
So last year, one of the biggest problem that we've had was the internet. So this year we worked really hard to solve it. So we created, instead of having a captive portal, we now have just 3 networks that have a simple password like friend12. The 3 networks should be easy to detect. iPhones will not see the fast network because it's a 5 gigahertz, but everybody else should be able to access them. DevHouse from Finland is helping us with the system infrastructure for the conference. And even before we got to improve the Wi-Fi, we actually increased the bandwidth available at the conference. We now have a symmetric 100 megabit fiber to the home network that we hope it actually is going to help everybody's internet experience at the conference. So we won't see any more negative tweets about the internet at EuroPython.
Shut down the internet.
Yeah. Actually, if it doesn't work, it's probably a leap second bug, or EC2 is down, or it's the cloud, whatever. Not us. It's just a very bad week these days. Anyway, just kidding. If there's a problem with the internet, and we know it's likely, there's problems for everything. There's red shirts guys with Wi-Fi written on their back. They're going to be outside throughout the conference. Talk to them. They're there to help us, and they're there to help you more of anybody. So as we said earlier, this year's conference is 10% bigger than last year. And we decided that we needed more area, more break area, since also we increased the stand area. So we now have access to the backyard garden. You can access through the garden from the side of the front desk, on the right of the front desk, and just walk around the hotel. And there will be a nice shaded garden that everybody can enjoy for their breaks. Talk about lunches.
Yeah. We also have some initiatives, and one of these is the women lunch. It's on Tuesday, 1 o'clock. You can talk to Lean Roots to join the lunch and take the tickets in the front desk. And a side note, I'm very happy to see that we have more women this year. Okay. And last year we worked very hard with all the attendees to tell them that we really need more diversity within the Python community. For a lot of reasons that I don't have the time to speak about, but talk with them and ask what they're doing with Python, what are their ideas, and if you have friends that are not coming this year, tell them about the next year. Okay. And we, like the last year, we have the pizza lunch daily. We increased the room, so we now have 80 tickets for each day. So if you want to have pizza for lunch, you can just grab the ticket in the front desk for the next day, and you can go and eat some pizza. Okay, another new feature. We have the help desks. So some projects that and some experts that will help you to go through some problems, some questions, and so on. You can go to the website and book your place for the help desk. The availability is very limited. So go and book your place. And you can take a look at of times and help desks when are they happening. And it's on the first floor near the lobby. Okay, so, and also book your trainings. You have limited cap for the trainings. We are doing, like the last year, 4-hour trainings. But the rooms are not so big. So go now to the website and book your place. Otherwise, we cannot accommodate everybody. And also, you have the chance to customize your schedule through the website and do some search, have some information about the talks. And also, you can download the guidebook app, and it will help you to do your schedule and browse offline during the conference.
Another new feature for this year is an internet. So we managed to carve a small room in this area, and we can host either your machines if you brought them, or we can create a small virtual machine so that you can deploy your software and run your software from within this network. So even if there will be, or there might be problems with the internet, we will be able to make your demonstrations, your training talks, your help desk a lot more fluid and a lot more problem-free. Together with this, it's the first time we try this, is that we have live streaming. So from the front page of the EuroPython site, we are hosting for all the rooms in the conference live streaming from here, and also available on the internet on YouTube. Just don't all go there at the same time, otherwise we will have problems with the internet. After all, you're at the conference. So in your badge, there's a lot of different pieces of paper. For the lucky of you that got invited to cocktail parties right after the conference before dinner, you might have the invites in your badge. You also have the Pi Fiorentina brochure if you bought it and you decided to participate at the dinner. And if you requested the prepaid phone card, it will also be there. Scrap the number so you get the PIN and you can browse. So today, this afternoon, there will be a Q&A with Guido. Go to Google Moderator, ask your questions, vote on questions that you want to be answered. Armin will host the session and will facilitate all the questioning that you guys want to do. If you don't ask questions on Google Moderator, it's going to be complicated to evaluate which questions are good and worthy and which are not. Also, Armin, if you want to step in on this.
It's true. There will be lightning talks today. Who knows what a lightning talk is? Wow, that's around 60% for everybody else. Can you hear me? I just shout louder. Wow, hey, I can talk wide. A lightning talk is a talk about any topic. It may be related with the conference, that helps, about at maximum 5 minutes. Lorenzo promised me there will be a flip chart outside. Please just register title of your lightning talk, like Python is great, and your name, Guido. You should give your last name if you are not Guido. So Guido van Rossum if you're not Guido van Rossum. So I can call you, and please be here with the lightning talks. The schedule will be very, what do we call it today, dynamic or agile? It will be made on the spot. So, join us for the lightning talks. Thank you.
So, very fast, stay hydrated. We have water all around. You can pick a cup and drink. Use your MongoDB cups so we don't run out of cups. Okay, and okay.
So over this week there will be coding competitions. One Tuesday, the Python Riddle, and on Thursday the Google Code Jam. Register online through the website or through Google. There's going to be prizes and, I don't know, stuff. There will be sprints at the end of the week, of course. If you have not already booked your plane back or train back, attend the sprints, register to them, check the schedule so you can make the best use of your weekend time. And if you need more help, just ask Yellow Shirts. Don't throw yourself somewhere without making a positive decision. We are here to help you. And just ask all of us, Yellow Shirts. Enjoy.
Enjoy.
Thank you, Valentino and Fabio. And I'm happy to announce that a technical problem on the upstairs room has been solved. So whoever is sitting now on the ground and wants a more comfortable seat can join our upstairs room where the Guido's keynote will be streamed. Thank you.
Stairs. We cannot hear you guys down here, but that's okay. Okay, sorry for doing all this live, but that's what happens. Okay, blah, 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 blah.
Have your data servers on the international space?
I didn't mean to show my email, but where is the... Yeah, okay, all I have to do is hit one more key, and that's as good as it gets. Presentation. Let's see if this time I won't get my screensaver kicking in all the time. Okay, I'm told that I have to wait for half a minute, so you all just have to exercise your patience. I didn't get the joke. Ah. Yeah. Can you hear me?
Okay, so I think that we can start with Guido's keynote. I'm not introducing Guido because, I mean, he needs no introduction at all. So,
okay,
Guido,
thanks.
Thank you.
Okay, take it away. So, I always like to thank the Python Software Foundation. They do have some presence at this conference. They helped a lot of Python things possible. They were, to some extent, involved in this conference, if I understand correctly. Of course, the conference organizers are largely independent, so that's also great to hear. Just sort of this particular photo, I think, is so cute. There's this woman in Japan who, for some reason, developed a skill of creating logos of software projects in lattes. And one day, she's gone through many different open source projects. She does a new one almost every day. And so one day, someone mailed me, hey, have you seen the PSF latte? And I thought it was really nice. And it turned out that she had actually done some contracting work for Google. And so we got to chat, and she showed me how she did it. At least she showed me a little video of how she did it, which is really cute. I think you can probably find that on geeklatte.omase.com, which is her URL. But it's quite interesting how the foam gets sculpted and sort of blown into the right shape with little sticks. It's a very Japanese thing I think, to do this. So the Python Software Foundation in my favorite coffee drink. Someone's mumbling on my line. Go backstage if you want to go mumble. Okay, so this talk is about trolls. I have to apologize if you came to PyCon earlier this year, because it's pretty much the same talk in the sense that I'm using the same slides and the same silly pictures. However, since I have absolutely no idea what I said last time about each of these topics, and I have no way to sort of separately display my notes and also present, I'm going to be completely ad-libbing. So don't expect this to be a literal repeat. On the other hand, if you did attend that talk, it's probably going to. There are some things that will definitely feel like overlaps, and if you catch me on a contradiction, that's great, because then you know what it feels like to be always sort of beholden to have an opinion on everything. Well, sometimes my opinion differs on the day of the week. So anyway, the idea of this talk is to go over a number of popular trolling subjects that people bring up. In the Python community, there is not that much trolling that I'm aware of. I'm sure we have the occasional person who keeps asking the same annoying question, and we all wish them to go away. But that's not really much of a problem. But sort of when I meet someone outside who is in the sort of computer world but not themselves programming much, and I say, oh, I created the Python programming language, well, usually it must be someone else who is with us at the time who would be saying that, because I rarely come out and say I created a programming language, because that's literally a conversation stopper. That's most of the time that's not a good way to introduce yourself at a party. But when the topic comes up, people usually have heard of Python, and so they bring up silly things like, oh, isn't that horrible language that has the global interpreter lock? Or how can you live with yourself given that you invented significant white space, or something like that? Or sometimes they'll just say, oh, the tabs, the horrible tabs. So there are much more subtle and actually much more interesting questions that also come from that corner. And I have thought about various kinds of answers, and I'm sort of bearing my own heart a little bit here, what I think about some of these topics. It sort of goes from trolls to actually fairly controversial stuff. So, yeah, what is a troll? You can ask yourself, do I look like a troll? If you have a problem with the troll in some mailing list or some other forum, usually the best way is to not respond at all, because that's how you deal with trolls. That makes them go away, because they they want you to engage in their argument. So if you don't engage, no troll. Everybody happy. Well, maybe not the troll, but that's their problem. So it used to be, and I'm so glad that this is finally over. I don't know what happened exactly, but the white space was for more than a decade the first thing that everybody sort of complained about and brought up, especially the people who had never used Python before. And so that particular one was actually, in the end, sort of, there's a pat answer that you've probably all learned to give, which is you must not have tried it yet. Because everybody who tries Python, after a few days or a week or a few weeks, they don't notice the white space anymore, and they actually miss it when they have to go somewhere else. So there are other trolls. Here's a very common one, language favoritism. Python sucks. Now I'm picking on Ruby because Ruby is actually the closest language to Python in general. And yeah, there are some very enthusiastic Ruby supporters who think that Python is an abomination. I'm sure that some of you think the same thing about Ruby. But you can substitute any other language. It's static versus dynamic typing. Oh my gosh, yeah, we once had a Python program at our organization, and then they replaced it with a Java program, and it was so much faster. Well, guess what? The opposite happens just as often. From my perspective, this is all pretty silly. There's not going to be one programming language at any point in the future. There will be multiple programming languages with multiple purposes, multiple sort of advantages and disadvantages. Well, okay, I don't know about 3 million years in the future. I mean, everything from viruses to humans uses the same genetic code in DNA. So there is a precedent for sort of universal standardization on a single language. But it's not very common. I mean, beyond that, there's usually variety, and for a very good reason. And there's a reason that at the moment languages like Python and Ruby and JavaScript, which are all modern dynamic programming languages, and I should mention Perl because it also sort of paved the way for Python and Ruby to become more popular. All those languages, if you look at them from 30,000 feet above, or maybe I should translate that into kilometers, so 10 kilometers away, they're actually all pretty much the same. They have things like garbage collection, memory management in general. They have a large library. They're largely open source. They have a community that really loves the language. They have lots of third-party packages that are being developed by that community. They have lots of commercial interests who are sort of working with the community, creating businesses on the side, creating businesses, developing commercial software, or doing consulting for open source software, straddling the line. Large organizations like Google and NASA are using these languages internally. There is a lot more in common than sort of what divides us really is the way I think about this. Even Scheme, which is like syntactically so completely different from Python or Lisp, is actually very similar to Python in many other ways. They're sort of dynamic languages, and whether it's Python or JavaScript, and you can say all you will about JavaScript, is not my favorite language either, but it's a language you cannot get around to knowing in many fields these days. And actually, those languages are all dynamic languages. They have a lot of things in common. They don't just have garbage collection, but they have objects, that are self-describing. If you find a pointer and you know that it's a pointer to an object in Python or in any of those other languages, by just sort of knowing what the internal representation of all objects is, you can learn what kind of object that is. And you can find out everything about it. And sort of this introspection and this sort of not having to have some kind of model in the compiler that is not available at runtime, but only in the compiler that tells you what the layout of the object is a common thing between all these languages. Actually, in a sense, even Java has that. C++ does not have that. In C++, if you have a pointer, it could point to a byte or a bunch of bytes, and you have no idea what that is. And if there's an object at the other end of that pointer, you better already know what kind of object that is, otherwise you won't be able to interpret the methods of that object. So, in some sense, dynamic languages are a group of very closely related languages. We can probably learn from each other. One lesson I'm learning still is that dynamic languages have been incredibly successful. Not just Python, not just JavaScript, but the whole group of dynamic languages have been so successful that you now see proponents of static languages try to figure out how to build a bridge between the static languages and dynamic languages. You see language designs like Dart developed by some Googlers that I don't actually know personally. I don't know that much about Dart, but Dart is trying to bridge the separation between static and dynamic languages in one way by adding optional static typing to an essentially still dynamic language. There are also people approaching it from the other way. They're trying to design statically typed languages that still borrow ideas from dynamic languages somehow, because they're concerned about they're concerned about market share. They realize that so many people are using and loving dynamic languages that the meme that static typing is always better is sort of getting out of fashion. And so I say you should all pride yourself in adopting dynamic languages, and don't worry too much about the difference between Python and Ruby and Perl and JavaScript. Let's see what else I have, because I've probably anticipated some of my next slides. Oh no, this is a completely different topic. Also commonly used as a troll. Python, oh yeah, that's the language where you try to introduce a new version of the language, and I hear that nobody is using it. So when are you just going to admit that it was a mistake? Well, if you look at my license plate, I'm the last one going to admit that it was a mistake. I don't think any one of you here believes that Python 3 is a mistake either. Now, I almost don't dare to ask for a show of hands who is using Python 3. I'm still going to do it because I know it's going to be a disappointingly small number still. So who is using Python 3? Okay, core developer. Actually, that's a larger number of hands than I feared. Who is using Python 2? Okay, very good. I think I saw some people who didn't raise their hands either way, so they must be here to learn. Oh, Python 1, yeah. Well, frankly, when we started the Py3K project, we knew this was going to happen. We totally anticipated and expected that it would take a long time to get people to move to the new language. And every year, actually, I see the situation improving. For example, NumPy, a large Python library that is very important in the scientific community, has good Python 3 support these days. That's new. A year ago, they were very reluctant. They said, well, yeah, we know we have to do something about it, but we're not sure that when we want to do it, because we're already short on people to do things in general with NumPy. I'm very glad that they sort of skipped over that barrier and actually started looking into porting NumPy to Python 3000 and found out that it wasn't actually such a huge deal. Yes, it's sort of, it takes effort. You can't just magically translate your Python 2 code in Python 3 code or your Python 2 extension modules into Python 3 extension modules. You have to understand what the code is doing and manually make adjustments even after you've run the mechanical tools that in some cases exist. There is always the problem of what do I do with users who do not want to switch to Python 3 because some other thing that they're using hasn't been ported yet. So they are somehow tied to Python 2.5, say, or 2.6 or 2.7. How do I deal with those users? Well, when we started Python 3, we weren't sure about the strategy for supporting Python 2 and Python 3 at the same time. We did think about the strategy for porting code to Python 3, but the idea originally was when you port your code to Python 3, you abandon Python 2. Your Python 2 users will still have access to your original Python 2 code, of course, but your Python 3 users will be getting all the new features and Python 2 will not. It turns out that many people have somewhat independently and eventually collectively discovered that there are different approaches that make it quite feasible to use a single code base or almost a single code base to support both Python 2 and Python 3. I'm not going into sort of the details. There are a number of different strategies for doing that. I'm just noticing that more and more people are actually figuring out that it's not the end of the world having to support both Python 2 and Python 3. And you can actually do it reasonably well. We did make one tiny compromise in Python 3.3. String literals prefixed with the U are back in Python 3. It turned out that in Python 2.6 and 2.7, we introduced a B prefix for string literals as a sort of a no-op that meant this is an 8-bit string, but without any suffix, it was also an 8-bit string. So in Python 2, it was a no-op, but you could sort of use that to have Python code that would work in Python 2 and in Python 3, and the things that in your Python code you were using as raw bytes. If you mark those with a B prefix in Python 2, they would remain bytes in Python 3, while if you left out the B prefix, they would become Unicode literals in Python 3. Well, it turns out that there is sort of a converse use case where people explicitly mark their Unicode literals with U, and they've been doing that for a long time, and they don't want to have to scrub their code to change all that. And so now if you can live with not supporting Python 3.0, 3.1, or 3.2, but you're sort of okay with supporting Python 3.3 and going forward, as well as Python 2.7 and 2.6. You can actually do that a little easier because of the U literal. It means that you can use the same code base a little more often, and you can mark your Unicode strings explicitly in your code base. Of course, in Python 3, the U prefix is completely redundant because without that, it's also a Unicode string literal. It behaves exactly the same way, but nevertheless, it somehow helps one particular strategy of dealing with supporting both versions in one code base. That said, in general, there will still sort of, until you can completely abandon Python 2. Yeah, I'm sure you all were waiting for that Freudian slip. Until you can completely abandon Python 2, you won't be able to completely get all the benefits of Python 3. But there is a huge transition period where that's just the way of life. And if you've sort of migrated Python code from earlier versions of Python 2 to later versions of Python 2, you've already dealt with the same pain of sort of new style classes versus old style classes, many other features, the with statement that was available in Python 2.5 and upward, but in 2.5 you had to also import it from the future because with was a new keyword introduced at that time. There are certain things you have to do to sort of be happy across multiple versions. I think my feeling is that at this point there isn't that much extra work to be done to have a similar feeling of compatibility across Python 2 and Python 3. If you stick to the last Python 2 versions, 2.6 and 2.7, I mean, if you can stick to only 2.7, that makes it a little easier, but 2.6 is also a good stepping stone. So we see, what I see happening is more and more people porting stuff to Python 3. Everybody is always waiting for the other one to make the first move. I'm glad that a lot of people actually are choosing to make the first move because in the end it will benefit you to have a Python 3 version of your code at the moment that someone suddenly asks for it. And more people will be asking for it. That's just sort of, part of that is just a natural human tendency to like the latest and greatest. You want the new version of Windows because it's there, not because it's better. You just sort of, you may, and you know in your heart that's nonsense. But nevertheless, that's what happens. And the first time you see the new versions of software X, you think, oh my gosh, they just sort of made it look prettier to make it look different, and now I'm supposed to want that, and I'm going to resist that. 2 years later, you see the same thing, and it feels like, yeah, that's what I've been using for a long time, and then you see a screenshot of what the old thing looked like 2 years ago, and you think, oh my God, did I once think that was the latest and greatest in modern interface? Sort of, I see it in websites all the time. If someone sort of upgrades their website to a new design principle, like Google did actually about a year ago, you think, oh my gosh, why did they have to change everything? It looks weird, and I can't find my familiar features. But after a while, you get used to the new thing because you can sort of opt out for a while, but at some point you'll get the new version anyway. And then you see the old version and you think, oh my gosh, that looks really crummy. That is so dated. That is so late 90s or something. Hey, stay off my network. Well, so that's going to be a little painful. Let's see what happens when I hit the right arrow key. PyPy, another great topic for starting contentious discussion. Why aren't you all switching PyPy to PyPy? Why aren't you putting all your force behind PyPy? It's so much faster. Their benchmarks prove it. Why not just abandon CPython? Well, okay, I believe those benchmarks, and still I don't believe that PyPy is always better. It certainly it has a compatibility problem, and I'm very glad that the PyPy people are taking that compatibility problem so seriously, because they've chipped away at it, and they're making it better every time, every year, every time there is a new PyPy release. It's not only faster, because Armin had some other brainwave and rewrote the meta JIT generator compiler again, but it's also, they suddenly managed to support more Python extension modules, more standard library modules that are implemented in C, because they really care about the feedback they're getting that, well, it's great to be able to running a pure Python program 10 times faster than CPython can. But many users, even though they would love for their CPython to run faster, they're also using 25 extension modules, 3 of which have not been maintained for the last 3 years, but they still work. 4 of which they have written themselves and have no idea how to port those to PyPy, and so on and so forth. So running existing extension modules work under PyPy, it's still a moving target, but my understanding is that the PyPy project is doing a great job there. So I'm open for, at some point, PyPy taking over as the reference Python implementation or the preferred Python implementation. I think they still have some work to do in the Python 3 department, though. Although I don't actually know what the situation there is. I think I saw that Armin is going to give a talk about the state of PyPy later, so I won't have to worry about announcing anything there. But still, sort of, what is the relationship between PyPy and CPython? I've always been sort of flattered and excited and encouraging when people started to create their own alternate implementation of Python. And several of those have sort of reached quite a bit of community acceptance, and sort of they're building their own ecosystem. Jython was the first. It was born as JPython, but then someone else decided that they owned that name. So we didn't want to be linked to that organization forever, so now we're calling it Jython. EuroPython is definitely still alive and kicking in the .NET world. PyPy, they've always sort of helped me see which parts of Python were essential and which parts of Python were sort of an accident or just sort of something that just happened rather than something that was carefully designed. And we've gone back at various times and changed our habits, changed our coding style, sometimes changed our language implementation even to sort of accommodate the existence of other implementations of the language. We've never actually made it to an official specification of the language. It's incredibly hard work to have a formal specification of a language that is actually formal enough for a language designer on Mars to implement the language correctly and sort of have any hope of interoperability. So we don't do it that way, but nevertheless, we sort of gradually arrive at sort of delineating which parts of the language are part of the language and which parts are really CPython implementation features. For example, reference counting is definitely a CPython feature that does not have to be copied by any of the other languages. On the other hand, the fact that you have automatic garbage collection of some sort is probably at this point a language feature. I sometimes push for sort of considering things language features that other people would consider quality of implementation issues, like is a particular popular built-in function fast, or is it sort of, can it be executed in constant time? Say the length of a list or a string. That's not something I would ever be comfortable with, something that would have to be calculated by walking over the entire string and finding out how many characters there really are. So all Python implementations have to have a len implementation for at least for sort of core objects that can execute in constant time. Dictionaries being hash tables and everything that comes with that in terms of lookup time and asymptotically, but also sort of security issues. I consider that part of the language specification, and if you were to implement your dictionary using a balanced tree kind of implementation, I would not think that that would be a very Pythonic implementation, and you'd probably end up with all kinds of problems where the performance of your tree would be vastly slower than the performance of the hash tables that all Python implementations use. So, all Python implementations have a chance of sort of becoming the most popular Python implementation. And if at some point PyPy wins that race, great, then I can retire even more fully than I already feel I'm retired. On the other hand, CPython isn't dead yet. It's still a place that a lot of people like to use, a lot of people like to hack. So we'll keep doing that, and may the best party win. So now we have the dynamic typing troll. I already discussed a little bit that when the my language is better than your language slide was up. Yeah, static typing used to be something that was sort of, it was taught in all computer science courses. The importance of static typing, and sort of the attitude that was taught was static typing is better than dynamic typing because your compiler will find bugs that a dynamic language will only find at runtime. And it was literally presented as an advantage of static typing, and often there were other sort of reasons brought up for static typing, but for the longest time dynamic languages were sort of this underground movement that weren't even taught at all. You still see places where all languages being taught, whether it's C++ or Java, that's usually the entire manual of languages in places like that, but all languages being taught are statically typed languages. And there are still, I mean, I will not deny that there are situations where statically typed languages catch errors before dynamically typed languages catch them. I do deny that in the end, in most cases, relying on the compiler to find your bugs for you is a very good strategy. There are many, many recorded situations where horrible, horrible bugs in code that was compiled by a static compiler went unnoticed because usually the type system that the compiler implements is only fairly limited. It may know that a floating point number is not the same thing as a string, but it may let you cast floating point numbers to integers and back without giving a peep, even though sometimes the conversion loses precision. And guess what? Even at runtime, they don't generate code that detects losing precision. So if you, I mean, there are many statically typed languages where you can have operations that at runtime do horrible things, and because the compiler thought it was okay, it's just defined as the top 16 bits of your value disappear into thin air, for example. A different example of sort of type systems not helping you find bugs is null pointers. If you ever work with Java, you know what a null pointer error is. It's a horrible thing. Compilers don't do anything about it. And it's very easy to have sort of one group of programmers who are writing one set of interfaces have a convention that for certain conditions they'll return null pointers because the caller knows best what to do with that, and they couldn't think of a convenient exception, or the exception would just be a lot less convenient for various reasons. So they pass null pointers around, and sort of there is a silent assumption that you have to check for null pointer before you start using your pointer object. And then a different group of programmers is working on a completely different set of interfaces. and the implementations. And they have a different idea, and they may not ever have encountered null pointers, but somehow they never check for the presence of null pointers because their APIs never return null pointers. And now somehow they call an API that follows the other convention, which is that it's possible to return a null pointer. And now they don't do very thorough testing. They just sort of write some code. Of course it compiles. Then they run it in some simple cases, and they never encounter the sort of unusual circumstance where that other API returns a null pointer. And so they think their code is fine. And now they deploy to production. And it starts failing with horrible null pointer exceptions. In a sense, that's sort of a dynamic aspect of a language that sort of prides itself in its static typing. Because Java is definitely one of those languages where you have to sort of type each class name 3 times before you actually have a variable of the right type. And of course, there are many other examples too. For example, feet and meters, or in general, different units. All sorts of things that type systems don't capture. And in academia, people propose all kinds of sort of extended type systems that can capture that, and especially the thing about units comes up over and over again. And several people have written Python modules that also support specifying scientific units and sort of automatically getting feet out of a value specified in meters, or complaining when you add feet to cubic feet or something like that. But in practice, not enough people use that. So what are you going to do? Are you going to just sort of sit there and throw your hands in the air and say, well, yeah, all software fails? Well, sort of the end-to-end argument is, yes, all software will fail in unexpected ways, but you can sort of still improve your chances by doing certain things, and the things that you can do are actually pretty much the same for statically typed languages as they are for dynamically typed languages. And that is write unit tests, write integration tests. Think about your code. What is this code doing? How could it fail? What failure conditions are we likely to encounter? What if that API encountered a problem? Or very, very popular these days, what if that API went out to the net and had to wait for a minute? Does that mean that everything else that I'm doing here also has to wait for a minute? Those kind of bugs, you can't squash them by using a new tool. You can only squash them by thinking about your code, being smart about it, having multiple people look at the same code, working together, and testing. And of course, just you can also easily write a mindless suite of unit tests that has 110% coverage and still doesn't find the simplest bugs in your code. So, well, sort of, you can never stop thinking. You have to keep using your intelligence. That's the whole point of the software development industry. If at any point you think, oh, I can automate all that, leave it to tool X. Oh, PyLint will find all my errors now for me. No. In that case, if you really believe that, you shouldn't be in the software development business. You should delegate all that and sort of go make money or something. But in reality, we actually like to develop software, and we like to do clever things. So just sort of keep being clever and keep using the right tools. But sort of many different tools are useful. And there's no reason, there's no sort of, apart from something that is purely religion, there is no reason to have any problem with dynamic typing. And yes, if I could find all my bugs in my program, if only I used a statically typed language, I'd probably do that. but that's a pipe dream. That's never going to happen. So, and I'm just told that I only have 10 minutes left, so we'll see how many slides I have. Python is too slow for real work. Or what I often hear sometimes sort of severe newbies who sort of have just first encountered Python today or yesterday, but who've been in the computer field for a long time, often express their bafflement at there not being a real compiler, as they call it. Because they're so used to sort of all their problems being solved by using a compiler. Well, really, if it was so easy to write a compiler for Python, we certainly would have written one, but somehow dynamic languages are dynamic for a reason, and writing that compiler is not so easy. Now, there are some people who are still hoping to write that compiler, and I encourage actually people to think about the problem. It's a very interesting problem. And I hope that at some point static analysis, at least, will sort of lead to some kind of breakthrough. But at the same time, if you really think that Python is too slow for your program, then maybe you're not looking at it from the right angle, because there are many people for whom Python is absolutely fast enough. And for example, I hate to bring up examples from the Google universe again, because I'm not talking for Google here, but I do think that it's quite an accomplishment that YouTube is the largest website in the world, and it runs entirely on Python. Now, there are some qualifications to that, but nevertheless, YouTube, almost all the functionality in YouTube, everything that happens when you interact with YouTube, apart from the video codecs, is written in Python. Now, they developed a lot of custom code for that. They have their own web templating thing. On the other hand, yeah, web frameworks are funner to write than to use, it seems. But just sort of think about what that means. Python clearly is fast enough for real work. So that's what you can tell the trolls who say that Python is too slow. Oh, the global interpreter lock. I don't actually know whether to say Gil or Jill. I watched myself give this talk at PyCon, and I think I started out saying Jill, and then I switched to Gil. So you can say what you want. But realize that in most cases, the Gil is a completely non-issue. Python supports threading in the way that threading was intended to work when it was first invented. When threads were invented, computers had a single CPU, but they were running multiple applications simultaneously. And there was a switching mechanism between those applications. And obviously, when one application was using the CPU, the other application wasn't using the CPU, and that was all fine. That was sort of what it meant to timeshare. And most computers, until fairly recently, still did work on that model. The sort of the whole idea of multiple cores on a single chip and those being present in every computer that you can lay your hands on is a very new development. So what can you do when you really have to use Python and you really want to use all those CPUs? Well, build your application for scaling a little beyond that. Build your application in such a way that if you want to run it across multiple computers, it also works. Because now you have to somehow figure out how to deal with multiple copies of your app running and accessing your database or whatever it is that you use, and somehow having a locking mechanism between there. You've got to figure that out if you care about scaling anyway. Once you've figured that out, the solution for a multi-core computer is obvious. You just run 6 copies. If you have 6 CPUs, you run 6 copies of your app. And they all handle multiple requests using threads. But because there are 6 copies of the app, each of them has its own GIL. They coordinate between them through whatever locks you put on the database. And you're using your CPU very efficiently. So it's not really a big deal to work with that. Where it goes wrong is if you sort of take one particular interpretation of the multi-threading model, especially the Java model. In Java, it's incredibly expensive to start a new process. So in Java, they go out of their way to create multiple threads and use them rather than multiple CPUs. Sorry, rather than multiple processes. That is actually a language-specific bit of philosophy that doesn't translate well to Python. It doesn't make Python better or worse, in my mind. Now, if someone comes up with a way to get rid of the global interpreter lock, I'm all ears. But the reality is that every time someone tries it, they find that single-threaded code actually ends up running slower because it's not that you're getting rid of all locks. What you do is you get rid of the global interpreter lock by replacing it with finer grained locks, and that actually means many more locking operations. Because every time you touch a dictionary and you're not absolutely sure that a dictionary is not shared, you're going to have to lock it before you can look something up in it usually. And so those fine-grained locks now add to your performance, and if you're still doing that in single-threaded code, because maybe there's a background thread in your program, so you're not technically single-threaded, even though you're mostly single-threaded, it slows you down. You don't want that to happen either. So I'm looking forward to a solution that doesn't slow down the single-threaded situation, and maybe Armin Rigo has something with and I'm software transactional memory, and maybe he doesn't, because that's an exciting research area that I'm not going to predict what's going to happen there. It might happen, it might not. Okay, so we have a very severe time manager here, so I'm going to try and stick to it. So all these asynchronous things, it's great that they happen. I think it's very important that these things stay out of the core language, because there are too many different ways to do things. And often it's also that these things are still under development. And so here's a general thing about the standard library. The standard library is not, if you're a software developer, getting your code included in the standard library should not be your goal in life. Because once it's in the standard library, you're stuck with whatever mistakes you made. Standard library only gets released when the new version of Python gets released, which is every 18 months at the most, often more like 2 years. And we have very strict requirements for backwards compatibility. So you can't just sort of change your API because you came up with something better. You still have to support the old API for multiple revisions. This is the reason that the tools for working with web stuff, HTTP request handlers and stuff, that are outside the Python standard library are actually much better than what's in the Python standard library. Because what's sort of the latest and greatest way to handle web requests today may already be out-fashioned 6 months from now, or there may be an even more popular or even better thing that supports thread pools better, or connection sharing better, or whatever. And that's a world that moves so fast that it really ought to have its own collection of sort of best practice modules on the G-Shop package repository, instead of trying to get all that in the standard library and being sort of stuck with supporting the old APIs for the next decade. So, well, all those other async abstractions, keep experimenting, and once you have one that is universally liked and doesn't change for 5 years, we'll make it part of the language. Oh, Python in the browser, yeah, can't do it. It's political, not technical. Python in Mogul, can't do it. It's political, not technical. Those were quick slides. Functional programming, oh yeah. Reduce is not dead. It's just resting in some obscure library module. Lambda can't be fixed. It doesn't need to be fixed. Python is not a functional language. I mean, I love the functional language, the functional programming examples in the Haskell tutorials. Whenever I try to write some actual code, I never have the opportunity to do anything functionally because I'm always using Python to glue together existing APIs that are fundamentally stateful, and I'd just be writing lots of very obscure Haskell code to deal with the I/O problem, because I don't know what it is, but somehow almost all the Python code I write is mostly doing I/O and sort of not a lot of interesting computer science stuff. I just end up making a call to this API, and I spend a week figuring out what the right parameters for the API are, and then finally I have 4 lines of code that do what I want. So I don't see where functional programming would have helped me there. So, but nevertheless, I'm glad that functional programming exists, because sometimes you do encounter a problem that is perfect for functional programming, and then you should just sort of be solving it how you know to solve it using a functional programming language, but you can write similar code in Python in most cases. Okay, I already did my rant about the standard library. Don't strive for inclusion in the standard library. It's the wrong goal. Being a successful, I mean, if you want something specific to strive for, it would be one of the top 10 packages on the G shop or something like that, or have your download count be at least 5 digits or something, or at least 6 digits. Don't sort of hope that your code will be included in the standard library. Oh, garbage collection. Yeah, forget that. I mean, people can't even agree on the terms. Is reference counting garbage collection? You bet it is. It is a way of garbage collection. I once read a very interesting academic article that sort of compared garbage collection in sort of the Lisp-style garbage collection that doesn't use reference counts with reference-based garbage collection, and it sort of they proved mathematically that by the time you have added enough features to either of those algorithms to make them realistically sort of practicable, they're indistinguishable. So the optimal garbage collection algorithm is literally a clever mixture of using reference counts and not using reference counts. And since that is more or less what Python has implemented, I don't think we have anything to worry about or complain about. Yeah, stop changing the language already, except for you have to add my favorite feature. People will never stop doing that. So we grow the language slowly, and we also try occasionally to shed some old features, because otherwise it'll, at some point, every new language feature makes the language a little less simple and a little less easy to learn. And so at some point, the overall appeal of Python, as it's such an easy language to use or to learn or whatever, goes away, even though we've never added a sort of a poorly designed feature. Just the sheer number of features and how they interact might eventually drag us down. So that was one of the things we wanted to do with Python 3, was a big cleanup. So we ended up with a smaller language, so we could start adding new features again. Okay, well, the audience questions will be this afternoon. Can someone from the organization remind me what time?
Before the lightning talk.
10:30 now. We actually...
5:15. Okay, questions?
We do have 5 minutes for questions, super quick questions from both upstairs and here. Afterwards, there's 10:30. There's the coffee break, and after the coffee break, Alex Martelli will be giving his talk. Forgiveness or permission here.
Yay, Alex!
So, any question?
Here's a question.
Well, maybe not that much a question, maybe just a suggestion. You asked how many people use Python 3. Do you maybe want to ask how many people would like to use Python 3?
If you want to know the answer to that, I'll ask it for you. How many people would like to use Python 3? Hey! Well, don't all wait for the next person to be the first. I mean, it's one big game of chicken where nobody wants to sort of... Everybody sort of fears this situation where they're the only one in their peer group who uses Python 3 and they won't be able to cooperate with the rest. In fact, if you're using the first in your peer group to be using Python 3, you'll probably be a very big motivating factor for the rest of your peer group to also start switching to Python 3, because now they can ask you, how did you do it and how does it feel? And that helps. So don't be afraid to be the first one. Okay, another question.
What did we remove from Python 3 that was in Python 2, besides new style or the old style classes? Like, all the keywords are still there, right?
Well, the keywords are the least interesting part of the language. What did we remove? Yes, we removed old style classes. We removed the distinction between short and long integers. We removed a lot of nastiness around Unicode. Now, you can never avoid nastiness around Unicode completely because most people don't understand Unicode. That's what I find. I mean, we have a Google internal list where people ask Unicode questions. And time after time, they will not understand the difference between UTF-8 and Unicode. And that is the fundamental problem. And sort of, I start just pointing people to an introduction about the different encodings versus what is Unicode, because that's the only way they will ever understand what went wrong in their program. Oh, we removed many little things from the standard library. We really did remove quite a few crafty things. We removed the input function that evaluates the string you type as an expression. And so we could rename input raw to input. There were many, admittedly, the things we changed were mostly small things. I think we removed quite a bit of code that I wrote in early 1992 or so for dealing with what at that time was my research topic, which had to do with multimedia, mostly various antiquated audio file formats. I think we also removed support for a bunch of platforms that nobody has heard of in about a decade.
Any other question?
The subject must have been brought up before, but how do you feel about financial incentives to bringing more packages to Python 3?
The BSF is actually offering bounties or sort of offering to help sponsor porting important packages for Python 3. So that's happening. That's all that I'm feeling about that.
When will I be able to run my Python 3K code on App Engine?
That's a Google question that I can't answer you, but I want it just as bad as you do.
There's Google Compute Cloud now. You can use that.
Well, that would be one answer, but...
Okay, so we've run out of time. Thank you, Guido. So now there's a coffee break right outside. You will be guided, and Alex Martelli will be giving another keynote later on. Remember, fill out questions on Google Moderator.
Very lively talk, really liked it.